Hello everyone, my name is Vaibhav Kumar. I'm a student at BC Bhagalpur pursuing my BTech in Mechanical Engineering. In this video, I'll be giving a small demonstration of my project on machine learning using Python. I've learned this course from Skyfi Labs. In this project, I've designed an algorithm for predicting the prices of the house in Boston. Now moving on to our algorithm. This is our algorithm. We have used 4 libraries here. We have used NumPy libraries, Pandas libraries, Matplotlib library and sklearn libraries. Now talking about NumPy, it is a library for Python programming language. It is the foundation of machine learning stack. Now talking about Pandas, Pandas is one of the best libraries of Python. It supports reading and writing Excel spreadsheet. Talking about Matplotlib, it is very powerful plotting library useful for those working with Python and NumPy. Since we are working here with Python and NumPy, so we will use Matplotlib here. Matplotlib is some bit like our MATLAB, we can say. Now we will import some functions from this libraries like plt function from Matplotlib, func function from Matplotlib, mean max scalar, load Boston, mean squared error, trend test bridge. These functions from sklearn libraries. We've also imported html function from IPython to display the data. Now we have imported the Boston data from sklearn libraries and stored it in a variable named Boston. Then we have printed this Boston. The values are here. In this data we have 13 attributes and 506 instances. Now we will store these values, the Boston data, in a variable named feature, and then we will print this features and we will get a table format data shown here, in which we have 506 instances and 13 rows, that is 13 rows, 13 data. Now we will take out the age column for our purpose and we will display it here. Then we will again create a variable and store the target attribute in it. And then we will calculate the max and mean values of this target attribute, which comes out to be 50 and 5. This 50 and 5 lies somewhere in between these data. Now again we will create a variable and we will concat the target values in the above table, and we will store that table in our new variable, that is df, and then we will print this df. So here we can see we have 506 rows and 14 columns. This 14th column is the target column that we have concatenated in our previous table. Now we will round off these values to 2 decimal places using round function. So we have rounded off these values. Then we will again use a Pearson function, Pearson correlation coefficient, we can say. Now what is Pearson correlation coefficient? The Pearson correlation coefficient can be used to summarize the strength of the linear relationship between 2 data samples. So we have calculated this core variable and then we have stored it here and we have displayed it in a table format. Now we will write the codes and we will display these table data in a bar chart format. So we have used Matplotlib libraries to do this. We have used plt.figure function, plt.bar, plt.xlabel to label the x values, plt.y label to label these values. Then we have used plt.xtrace to have these values here, this 0.1, 0.2 and else that rm values. Then we will use the function plt.show to show the graph here. We have got here, we can see here we have else that as the highest value around 0.8 and then rm and then so on. Then we have taken out else that values and target values. Then we have printed the y attribute. Then again we have used the min max scalar function and we have reshaped the x values and y values, and then we have again printed the y. Then we have defined x train, x test, y train, y test accordingly. Then we have defined an error function. Then we have defined an update function with the attributes or parameters m, x, c, t and learning rate. Now before going forward, let's talk about our algorithm. Now what we have done here is we have defined an algorithm and then we have used the data that we have uploaded or imported from the sklearn libraries to train our algorithm, as well as check whether our algorithm is trained properly or not. So what we will do is we will divide our Boston house data that we have imported from the sklearn libraries into two containers. One container is used to actually train our algorithm, and the other container is used to check whether our algorithm is trained properly or not. So then we will update the values of mxc so that our algorithm can be trained properly. Then we will define a gradient descent function with the parameters as here. Then we will apply the for loop to check the errors in it accordingly with the error threshold values. Then we will iterate it. Now the iteration function is written here. Now talking about this percent time. This percent time is used to display the time that our function has taken or computer has taken to iterate it. Now initializing the init m values as 0.1, init c values as 0.1, learning rate 0.1, number of iterations 250, and error threshold 0.001. Now this error threshold value must be less than 0.0025 so that we can have a correct iteration values. So now we can see here we have 1 millisecond time that our iterations have taken. Now we will print the m and c values and we will plot the graph between x train and y train. This y train is, now we can see here we have two graphs here, that one is scatter graph and one is plot graph. Scatter graph is between x train and y train, and the plotted graph, that is this line graph, is between x train and a function mx plus c. It is a equation of line, that is y equals to mx c, where we have plotted the values between x train and y, where y equals mx plus c. We can see here this is shown by red line. Then we have again a plotting function, plt.plot, plt.y level, plt.x level. Then we iterate it. The text values are 0.50 and iterations. Now we will define here a variable predicted, that is equals to m into x test plus c. We can see here this is not other than y equals mx plus c, where y equals predicted, m equals m, x equals to x test, and c equals c. Then we will find the mean squared error between this predicted value and y test. That comes out to be 0.01206, and then we have taken out the x target y predicted values, and we have predicted the values. Then again we have plotted the graph between x test and y test, and again x test and the new predicted values. That comes out to be this. Then we have again written the code and predicted the y values, which are this. Hope you liked my video. Thank you.